Hello dear students, this is your physics teacher Ashish Sharma, and today we'll discuss chapter 2D after angular projectile. So now the topic is about circular motion and relation between linear velocity, linear and centripetal acceleration, angular velocity, and the derivation of formula of centripetal acceleration. Let us start. The first topic is relation between linear velocity and angular velocity. We already know about angular velocity that it is defined as rate of change of angle, that is in radian. So its unit is radian per second. Let us consider a small diagram in which an object has moved from P to Q traversing delta theta angle in delta t time. By vector analogy we know that r vector plus delta r vector is equal to r plus delta r vector. Now by basic concept, the velocity in this small time interval delta t, the distance covered, let us say it is of length delta l, then velocity is delta l divided by delta t, or we can write delta l is equal to v delta t. It is our first equation. Also we know that by definition omega is equal to delta theta by delta t, or we know that rate of change of angle, so we can write delta theta as omega delta t. Let it be equation 2. Now by definition of radian we know that angle in radian is equal to arc divided by radius. So in this diagram delta L is in place of arc and r is the magnitude of radius, hence we are having delta L by r is that angle. Now using relation 3, delta theta is equal to L by r, in relation 2 where delta theta is equal to delta L by r, I can put the value delta L by r in place of delta theta and results to the equation delta L by r is equal to omega delta t. Or I can also write this delta t in division here, and I can take r to other side and it will become delta L by delta t is equal to omega r. Let it be equation number 4. Now when I will put the value of delta L by delta t, because I can write my first equation as delta L divided by delta t is equal to v. So putting in place of delta L by t, I can write v. So this equation will become v is equal to omega r. So that is the relation between linear velocity v and angular velocity omega. So your relation is v is equal to omega r. Okay. Next is angular acceleration. Angular acceleration is represented by alpha. Angular acceleration is defined as rate of change of angular velocity. So the way like omega is equal to d theta by dt, your alpha is equal to d omega by dt. So alpha is equal to d omega by dt, or alpha is equal to omega 2 minus omega 1 divided by t2 minus t1. It is exactly same like acceleration a is equal to v2 minus v1 divided by time, or dv by dt. Dimensional formula of alpha is m0 l0 t raised to power minus 2, and relation between linear acceleration, which is also known as tangential acceleration, and angular acceleration. So we know that we just proved the relation v is equal to omega r. So differentiating both sides, left hand side will become delta dv by dt, and on right hand side d omega by dt, as r is constant, and rate of change of velocity is acceleration, and rate of change of angular velocity is angular acceleration. Hence the relation is at is equal to alpha r. That is your relation between tangential acceleration and angular acceleration alpha. Next is uniform circular motion. So uniform circular motion is when object is having constant angular speed in circular path. It is also known as uniform circular motion. But please note that uniform circular motion is non-uniform motion because it has centripetal acceleration even though it has zero angular acceleration. So we are having two accelerations in circular motion. One is your centripetal acceleration and other is your tangential or linear acceleration. So these two accelerations are there. If your a centripetal, if your at is equal to 0, or we can say alpha is equal to 0, then the motion is known as uniform motion, and uniform motion has non-zero AC, that is centripetal acceleration. So because if alpha is equal to 0, then it means at is automatically 0. So let me repeat you here, it's little confusing here. Circular motion has two accelerations. One is centripetal acceleration, that is due to the change in direction of object as it is moving in circular motion. AC is non-zero even when object is moving with constant speed in circle. But your A tangential or alpha will become non-zero if object speed is also increasing. Otherwise, when object is moving with constant speed, AC is non-zero but alpha or AT is equal to 0. Then there are few terms related to circular motion, that is time period. So time period is the time taken by the object in completing one cycle. How much time an object will take completing one cycle. Frequency is defined as number of cycles per second. Mathematically its formula is also 1 by t. It is also represented by f sometimes. And the relation between angular velocity and frequency is omega is equal to 2 pi nu, because omega is equal to 2 pi by t and 1 by t is equal to f, so it will become 2 pi f or 2 pi nu. Centripetal acceleration, as I was telling you, is due to the change in direction. Here is the derivation for centripetal acceleration. It is little tricky one step here, so please observe with full attention. Here we are having r1 vector radius, an object is at p, object moved to q, and here its velocity is v1, and then it's at this point q point is velocity is v2. Magnitude of v1 and v2 is the same but direction is changed, that's why they are different vectors, and it is r2, the second radius vector. Now note that angle between two radius vectors is theta between r1 and r2, and v1 is perpendicular to r1 and v2 is perpendicular to r2. This is perpendicular, free hand drawn, so ignore that, it is not perfect 90 degree. So both the angles are 90 degree. So angles between v1 and v2 must also be delta theta. So that is I have drawn here, angle between v1 and v2 must also be delta theta. So v1 vector and v2 vector both has magnitude v, and this change in velocity is represented by delta v, and also v1 and v2 both have magnitude v. So by definition of radian, your delta theta will become delta v divided by v, because delta v is the arc and v is at the place of radius. So delta v by v, because v1 and v2 both have same magnitude, that is v. So if delta theta is delta v by v, and I can write omega delta t in place of theta, because we know that omega is equal to delta theta by delta t. So I can always write omega multiplied by delta t in place of delta theta. So your delta theta is equal to omega delta t, that's it, is equal to delta v by v. And moving v on left hand side and moving delta t on right hand side, it will become delta v by delta t is equal to omega v, and delta v by t is nothing but centripetal acceleration, change in velocity by time taken, which becomes, and in place of v I can write omega r, so it will become omega square r. And if I will write in place of omega v by r, then it will become v square by r. So these two formulae are for centripetal acceleration. नेक्स्ट इज अबाउट टोटल एक्सेलरेशन। हेयर योर डाउट विल गेट क्लियर। यहाँ आपका कन्फ्यूजन अच्छे से खत्म हो जाएगा। जैसा मैंने आपको बोला कि सर्कुलर मोशन में दो एक्सेलरेशन होते हैं। एक एक्सेलरेशन होता है आपका बिकॉज ऑफ चेंज इन द डायरेक्शन ऑफ वेलोसिटी, बिकॉज एज ऑब्जेक्ट इज मूविंग द डायरेक्शन ऑफ वेलोसिटी इज चेंजिंग। सेकेंड, if the speed of object itself increases, which is moving in circle, then it means the acceleration is tangential acceleration at, which is also equal to alpha r, where alpha is angular acceleration. And second is AC, whose direction is always towards center, and a tangential direction is always toward tangent or linear acceleration. So total acceleration in circular motion with these two accelerations which are perpendicular to each other, then by simple vector addition, a is equal to AC plus AT, and as they are at 90 degree, so a is equal to AC square plus AT square whole square root. Special case if tangential acceleration is 0, which simply means that omega is constant and the speed of particle is not increasing, only direction is changing, so alpha is equal to 0, or we can say AT is equal to 0. So the only acceleration present is centripetal acceleration, that is equal to v square by r, और omega square into r, जिसका डेरिवेशन हमने अभी किया यहाँ पे। और अगर वो दोनों एक्सेलरेशन अगर AT नॉन जीरो है, देन विल यूज द फॉर्मूला A इज मैग्नीट्यूड इज इक्वल टू AC स्क्वायर प्लस AT स्क्वायर का स्क्वायर रूट। Let us have a numerical example. A motor car traveling at 30 meter per second on a circular road of radius 500 meter is increasing its speed at rate of 2 meter per second square. अब आप देखो यहाँ पे 30 मीटर पर सेकंड स्पीड से व्हीकल चल रहा है, तो इसका मतलब कि अगर हमारे को एक्सेलरेशन ना दे रखा होता तो हमारे को सिर्फ वेलोसिटी दे रखी होती, तो सिर्फ सेंट्रीपिटल एक्सेलरेशन होता, कांस्टेंट वेलोसिटी। लेकिन हमारे को इंक्रीजिंग स्पीड भी दे दिया, तो जो 2 मीटर पर सेकंड स्क्वायर आई है हमारा टेंजेंशियल एक्सेलरेशन हो गया। तो हमारे पास जो सेंट्रीपिटल एक्सेलरेशन है वो हम निकालेंगे इस वेलोसिटी और इस रेडियस से, और टेंजेंशियल एक्सेलरेशन हमारे पास हो गया 2 मीटर पर सेकेंड। तो सेंट्रीपिटल एक्सेलरेशन यूजिंग द फार्मूला v स्क्वायर बाय आर, v की वैल्यू 30 यहाँ से पिक करी हमने, और डिवाइड बाय आर किया हमने 500 मीटर, तो हमारे पास आ गया 1.8 मीटर पर सेकंड स्क्वायर। ये AC आ गया हमारे पास, ए टेंजेंशियल हमारे को 2 मीटर पर सेकंड स्क्वायर गिवन है। इन दोनों को हमने अपने फार्मूले में पुट किया, AC स्क्वायर प्लस AT स्क्वायर का स्क्वायर रूट, सो वी गेट A इज इक्वल टू 2.7 मीटर पर सेकंड स्क्वायर। वन मोर थिंग, इट इज एग्जांपल ऑफ नॉन यूनिफॉर्म सर्कुलर मोशन बिकॉज अल्फा इज नॉन जीरो, अल्फा प्रेजेंट है, और वी कैन से AT इज नॉन जीरो, AT प्रेजेंट है। अगर AT आपका जीरो होता तो ये यूनिफॉर्म सर्कुलर मोशन हो जाता। ठीक है, तो यहाँ पे आपका सेकंड यूनिट का डेरिवेशन पार्ट ख़त्म हो गया है, और नेक्स्ट लेक्चर में हम डिस्कस करेंगे इसके कुछ न्यूमेरिकल्स, और फिर हम स्टार्ट करेंगे हमारी यूनिट 3। थैंक यू, टेक केयर।